Okay, hello everyone, and welcome to my channel, Maths with Terry, Math Made Easy with Terry in 10 minutes. Okay, the last video, which I talked about integration by substitution, I gave you the 5 steps. So if you don't have the 5 steps, please go back to the last video and have a look at it and watch it. Then before you come to this video now, so because I'm going to apply those steps here to solve it. Now, remember I told you, we've talked about integration by parts before, but this is integrating products, but we're using integration by substitution here. I'm going to use this example to explain, okay, how to do it. Then I'm going to have another video as well with another new example. I'm going to see if I can solve 2 examples on this before we go to the next concept of integration by partial fractions. Is that okay? So for this, what do? So remember the first step, I told you that you have to rewrite the equation, right? So what I'm going to do is that I'm going to say let's, okay, I'm going to use u equal to cos x plus 1. Can you see? So I can rewrite this equation now as pi over 2, 0, e raised to power what? U sine x. Then remember, what's the second step? The second step is that you have to replace the upper limit and the lower limit. So in this case, it's a definite integration. Now, if there was no upper and lower limits here, you just go straight to step 3. So we have the upper limit is pi over 2. The lower limit is 0. So this is in respect to x, but we're converting everything to u. So we know the upper limit here. The upper limit here is pi over 2. And we know the lower limit here, which is what? 0. Okay? So we're going to find the u equivalent. So the u, we know u is what cos x plus 1. So u is going to be equal to cos pi over 2 plus 1. And that will give you cos pi over 2, that's cos 90. 90 is 0. And that will give you 1. And the next one, we're going to give you cos 0 plus 1, and that will give you what? 2. So that means I can rewrite this again to be, I don't know why my, okay. The upper limit here is 1, and the lower limit is 2. And we have exponential u sine x. Now the next step, like I told you, is then to rewrite what you're integrating with. Okay, you have to rewrite it again. I said rewrite what you're integrating with in respect to, okay, in this case here, u, and we substitute. So we know u is equal to cos x plus 1. Okay, now this is dot dx. Oh, sorry, I forgot to write it. This is dot dx. Okay, okay. So now du over dx is going to be, so in the previous video, I showed you from sine to cosine, minus sine, and minus cosine. So when you integrate cos, it's going to give you what? Minus sine. So that's going to give you minus sine what? X. But we're going to replace dx. So I'm going to look for dx. So dx is going to be equal to 1 over minus sine x dot du. Is that making sense? So it's be minus 1 over sine x du. Then we come back to the original equation we have here. We'll substitute it. So we have 1, 2, e raised to power u dot sine x. Now our dx, we substitute dx with this, which is going to be du divided by minus sine x. Can you see? So we substituted everything there. Now, what happens here? The sine x can cancel the sine x, and it's going to give you integrate 1, 2, minus eu dot du. Can you see? So remember, you have a negative sign there. So if you remember what we talked about, you bring the minus out. If you integrate exponential, to still give you the same thing. Is that okay? So this is going to give you, you substitute 1, so it'll be minus. When you substitute minus exponential, to give you minus eu into brackets 1 and what? 2. So that means you substitute when you have 1, minus when you substitute when you have 0. So minus E1 minus minus E2. And the answer would be the value for that, okay? So usually in some textbook, they just prefer to stop here, okay? And you can just put it in your calculator and it will give you the answer. So you substitute when you have 1 into this, minus when you substitute when you have what? 2. And yeah, and that'll be that for that, okay? In the next video, I'm going to solve another question, maybe one that has a fraction. And we're going to have some more similar using the integration by substitution method here. So quickly, just to remind us, for substitution, remember the aim of substitution is to replace all the x and dx with the new alphabet. So it can be u or anything. If it's a definite integral, you have to replace all the upper limit and the lower limit with the new number, okay, or the new limit. If it's not, you just jump step 2 and you go to step 3 and 4, okay? All right. That'll be that for that. And I'll just go straight to the next video. I'm going to solve one more question, and I'm going to try and see if I can solve a question on integral of a fraction using substitution method. So I'll see you soon. Don't forget to like and subscribe. If you have a question, please put it in the comment below. Thank you very much.